right? So we'll see one question now, very important question here now. So this ladder is at rest, therefore this ladder is at rest now. So what should be the minimum value of mu so that the ladder will be under equilibrium? Equilibrium means it's not falling down onto this, right? Not rotating. Here this side is smooth surface, this side no, this side it is rough surface no. We want to calculate this mu value. How to calculate this mu value now? Let us see now. So here under equilibrium means total force and total torque should be equal to 0. First let us balance the total force now. Total net forces now should be equal to 0. So what are the total forces now? Downward forces and upward forces both should be equal. What is the downward force now? Here therefore mg will be your downward force, mg, right? And this side it will be your upward force no. So there is, apart from this there is no other forces. Here there is no components here no because of smooth onto this. So therefore N1 will be equal to mg, clear, right? And horizontal forces, what is the horizontal forces now? This side force is nothing but a frictional force no, this side force is nothing but a N2 force, right? So therefore N2 should be equal to nothing but a frictional force, clear, right? So first we got the balancing of the forces now. Now we have to balance the torques. So it is under equilibrium means what will happen now? Therefore here whatever the forces are there no, or whatever the torques are there no, therefore that also should be equal to 0. Now we will calculate the torque at this point no, at this point, at point A. What is the torque now? So what at this point no, therefore this N1 is acting along this point no, therefore N1 will not create any torque onto this, clear? So therefore this N2 what it will do now, and this frictional force also will not create any torque no, because it is also acting at this point. So this N1 will not create any torque no, frictional force will not create any torque no. Which one will create the torque no? This N2 will create the torque, clear? So and also this M1 mg is there no, this it will create the torque here no, clear? So we will calculate the torques at this point no. So torque at A, right? So total torque at A should be equal to 0 because it should not create any external torque here now. Therefore this torque at this point here no, therefore what will be this one now? This N2, what will be the distance here now? This distance, right? So N2, okay, so perpendicular distance no, therefore this is your distance now, right? So suppose this total length is L, this perpendicular distance is nothing but a, so this is your opposite side no, therefore this is L sin theta and this it will be your L cos theta, clear? Yes or no? Therefore N2 into therefore N2 into perpendicular distance is nothing but a L sin theta, so it will be equal to therefore mg, therefore mg, so this distance we want no, therefore here this is L by 2, this distance is also L by 2 cos theta, this total distance is L cos theta, but in that half is there no, that is nothing but a L by 2 cos theta, therefore L by 2 cos theta, clear? So this L and L get cancelled out no, therefore N2 can be written as, so mg into cos theta by therefore cos theta by therefore sin theta, clear? So in this way therefore we calculated the N2. So N2 means here frictional force is there no, frictional force is N2, that's all. So therefore frictional force should be greater than or equal to, therefore this is N2. So N2 we got it no, therefore mg into therefore here cos theta by sin theta, clear? So frictional force what you can write it now, this what is the normal reaction at this point now, therefore mu into, so mu into N1, but N1 you know it now, mu into mg, so therefore mu into mg, therefore finally we can write down mu into mg should be, right, minimum value is said no, therefore minimum value should be equal to, so therefore mg into cot theta, clear? Mg and mg cancel no. Sorry here no, therefore here L by 2 is there, therefore this is by 2, so this is by 2, therefore here it will be the by 2, that implies here mu is equals to cot theta by 2 will be your answer, therefore cot theta, second option will be your correct answer. In this way you can solve the problems of the ladder problems no, just to create every time equilibrium means total torque should be equal to 0, total force should be equal to 0, that's all, clear?